Now, I made a short reference before about when you get a fault on an installation, the fuse or circuit breaker nearest the fault has to not only see it first, it must trip and isolate the faulty circuit, leaving all your healthy circuits intact. There is a test of which we call coordination and discrimination study. What happens after the software is designed the installation? We've got all that. That's all good. We've got our drawings, we're single lines, we're as-builts, we've got all our cable sizes. The last job we have to do is a coordination discrimination study. And what that does is the software looks at every protection device and then draws its characteristic curve on a log display on your computer screen. And then you can see very quickly and easily if you've achieved discrimination, because all them trip curves, them trip characteristics, should not overlap or touch each other. And if you've got daylight between them trip characteristics, trip curves, then you know you've achieved discrimination. This is a very, very time-consuming task. I remember on one job where I'd set up an incoming breaker, 4,000 amp incoming breaker against a high voltage fuse, 80 amp, 22 kV high voltage fuse. And I had to keep adjusting the time dial setting to achieve them trip curves where I had daylight between them. That took me almost a day. The software is so fast and powerful, it can plot and display 120 devices in just 4 minutes.